Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. It has been a long time since I did one of these, and I am super happy to see everyone back in the chat. Daniel Collin, DJ Hoffman is here with me, by the way.
Hello.
And we're going to go over our latest 64K. I'll go through the rest of the names really quick here. Luna Sorcery, Frizzy09, Trilater, Pyro ESP, Soda Design, Wister Tobe, Chief Detector? Not that your name is that confusing. I just don't remember if I read it yet or not. Anyways, it's been a while for me. I'll take a minute or two to kind of explain why. Basically, the last several months for me had a lot of change. Essentially, I changed jobs. I moved in with my girlfriend, and well, that's the main two things.
Did you know moving house is the most stressful thing you can do?
I did not know that.
Yeah, it's horrific.
I mean, I believe it. But yeah, so a lot of things going on, and unfortunately, streaming has kind of taken the back seat for a little while. But I'm back. I plan to start doing this at least one a week for now, until I've kind of set everything up. Yeah, Frizzy, I've got a green screen now.
I haven't though.
It's
so
fancy.
You can still see my walls.
By the way, hi Zero Repent. Sandals, what's going on? Anyway, we released a couple 64Ks since I streamed last. Oh, one more thing before I get into that, just so we're clear. I like I said, I do plan to start streaming again. I'm gonna do that once a week. I'm just gonna do Thursdays for now, until I kind of settle into things. And then I'm gonna actually have to consider if I'm gonna start doing the Sunday ones again too. I don't really know yet. But Thursday ones are going to start happening again, and they're going to be at a new regular time, which is going to be an hour earlier. And that's just because my whole life has shifted a couple hours to earlier now. So it's just a lot more convenient that way. But yeah, next week I should be doing some emulator stuff. But enough of that. Let's get into what we're actually here to talk about. We released a couple 64K since I streamed last. We did one called Bros Before Foes.
Yes.
I believe it was called. We did that with Tropical Trevor of Pooh Brain. And that was a quickie that came together really nicely. Super happy with that. And that won Evoke, didn't it?
Yes.
Yeah. So at some point I'd like to set up a stream with Trevor to talk about that. But, again, that's not what we're here to talk about. We're here to talk about Trashpanda, the 64K we just put out 2 weekends ago?
Yes.
Or was it 3?
I can tell you that.
One of those.
It was 3 weekends ago.
Yeah, that many.
Yeah, that many. 2.875, I think.
Yes, somewhere in there. Jack Pam, how's it going? Yeah, we released this at TRSAC this year. We got first place there in what I thought was a pretty cool compo. I think my personal favorite from the party may have been the second place entry, which was an 8K by Root Kids. Recommend you guys check that out. But anyway, this is Trashpanda. Just a really random name for a really random demo. And before I get too far into this, I think let's just watch this, and then we'll talk about stuff. I'm going to mute my mic and stuff, by the way. You'll still hear Ian, and I apologize in advance.
Yeah, I'll be quiet then.
All right. Yeah. So that is Trashpanda. Not much more to say about it. So stream's over. See you guys later.
Oh, see ya. Sign off.
Now this started sometime, I think actually pretty quickly after Bros Before Foes, but not necessarily like actually working on this demo. Let me see here. So let me get the little file browser thing up and running on Slack because I forgot to download all these files. At some point, right after Bros Before Foes, like in August, I think, I actually had a bunch of time off because, like I said, I was switching jobs, and I got a bunch of time off in August, and so I started working on some new stuff that I wanted to work on for a while. Particularly, I wanted to see if I could make like a nice deferred renderer, and so I started playing around with some stuff. The other thing that happened is, I think it was the end of July, assembly happened, and I was really inspired by a Fairlight and CNCD demo called Number One, Another One. So it first started with me just like experimenting to see if I could do that kind of this kind of ribbony kind of effect just with a bunch of instancing. It ends up looking really noisy, and I actually think the Fairlight demo adds a bunch of like grain and stuff over the image to hide that, and also I think they use like more environment maps. But it was kind of a challenge because I wanted to make the entire rendering pipeline within the demo tool. So just to show a little bit of that. Go back up here, like this scene. If I go in here, it's a bit hard to see because the graph here for this demo ended up being really large compared to other ones for other demos that we've done. If I scroll over here, then we've got like more scenes. And then over here, there's all the rendering pipeline stuff and all the lights and primitives. So a lot of stuff here. But if I go to one of the scenes here, let's see. I think this one's called, I don't remember. It's not that one. It's not that one. It's not Kick Dudes. Grow. It's called Grow. So if I do this, everything disappears except the background. Yeah, here we go. So the kind of goal that I wanted was like a renderer where it would be easier to kind of compose objects. Oh, this actually has another light in here we didn't use. So the whole idea is that I wanted to build functions inside this call graph that I could do to call to like add lights and add geometry. So if I take out some of this stuff, for example, a couple of the lights, you can see that it looks like this. I think also I have here some stuff so that we can move the camera around and see what this looks like. It looks a lot more lame with the camera head on like that. But it's kind of cool. So the whole thing is that I just want to make this really composable pipeline. And I ended up going with a deferred renderer for the whole thing. And so initially there's like a gbuffer pass, and then we draw on all the lights, and that's what allows us to really easily separate the two things. These two lights aren't very different, are they? This one I think is the yellow one. But the idea is that I can construct the scene function that just calls all these other functions to like draw the geometry and stuff. It's a bit, just the segments without the endpoints. It's a bit not that nice to look at in this graph, and I don't want to go into too much detail about like how that works because I think it's actually relatively straightforward in terms of like how a deferred renderer normally works. But just to show that this was kind of the idea, was to be able to compose things like this, and then also like these lights, like I can adjust their different color parameters and stuff. That one is not going to do much because that's not turned on, but yeah, just do this stuff a little bit easier and more live than I had before. And also it's a polygon renderer, so kind of went back to, I think Elysian was the last demo we did with polygons. No, Iota technically was. But I started this renderer from scratch in early August. And the initial stuff that I drew with that, again, was that ribbony stuff. Let's see if I can find more of these shots here. I had a bunch of these. And actually, it actually goes back a little bit farther with some of this stuff that I just realized, because I added a bunch of stuff to the demo tool. I've got a lot of stuff to talk about if I want to talk about all this stuff. But yeah, these are more test shots. These are just earlier things. Like the lighting here was crap, but I just wanted to make sure that I could do like spotlights and again have everything be composable with these different kinds of objects. But actually, I'm going to go back in time a little bit further to right after revision, because after I did IOTA with all the particles and everything, I ended up doing a couple tests with adding compute shaders to the demo tool. So one of the things about IOTA is that it draws all these particles and it calculates where they're going to be and does all the depth of field and everything all in the vertex shader, which is not the best way to do that. It may have been better to do, for example, a geometry shader where it will actually place the particle and then expand it, but we don't have geometry shader support in the tool. So another way to do it would be compute shader. So we would place them all in a compute shader and then just read those from the vertex shader. Also, I wanted to do like feedback particle effects. And so sometime, I think this was like mid-April, I started getting stuff like this. And this was a test to emit a lot of particles from like some kind of primitive. And you can see here, there's already like the background gradient and a couple other things. And I also knew that I wanted to start playing with opaque particles. And I didn't quite get there because I wanted to do like shadows and proper translucency on this stuff, but I just ended up playing with these kind of ideas. And let's see. That was probably some chat I didn't need to show. Man, I should have downloaded these beforehand. Anyway, I think there's one more of these I wanted to show. And so really, again, it's just testing that I'm emitting a bunch of particles from some kind of primitive, and it's the same depth of field shaders that IOTA had, so it's all this like blended stuff. And then I started playing with some other stuff too that's really fun. Like I started playing with a path tracer, which I just want to show now anyway because it's right here. Taking Engage and then making it a path tracer instead of a ray marcher, or instead of a regular ray marcher. So I did some tests with that, and that was pretty fun. I also went back and I fixed our bloom just to make that look a little nicer. We also added SSE, or we moved the entire synth to SSE, so that made it a lot faster. We also started working on something for Solskogen, but that didn't turn into anything, but I still want to keep that under wraps because there's some kind of cool stuff in there. And then I started getting to the stretchy stuff. But anyways, I was building this renderer. It was natural to just take that scene that I already had and just try to put that in there too. And so this is one of the earlier shots too. This is, as you can see, August 24th, so I guess this is later August. And one of the things I actually had to do to make this work in the tool in the first place... Oh, yeah, I forgot. Yeah, thanks, Daniel Colin. I did totally do a bunch of that SSE stuff on the stream. But yeah, one of the things to make this work is that when you want to do the shadow maps for the lights, you want to be able to have matrices that you actually manipulate on the CPU to figure out like what the light's point of view is going to be and transform everything into the correct space. With the demo tool as it was before, I didn't have the ability to do that. And so what I ended up doing is extending this. So originally I had variables that I could define here. It's going to be hard to read this, but I just want to show it briefly, where you have the name and then like a value. And these could be local or global, which is essentially whether or not it's pushing the previous value to a stack or not. I've actually extended this now, so instead of just having float variables, which are going to be 64-bit floats, this also supports matrix variables. And it moves all of the operators that I had for manipulating matrices kind of into the graph itself. Which makes it a lot more general purpose. So it's actually less code to do this. It's a little more code in the compiler, but it's less code in the intro. And then also allows us to actually store matrices like we would with any other variables. And that's kind of one of the secret things, or the like secret sauce kind of things to make this even work in the first place. So that was one of the earlier tests when I was getting that renderer running. Then I just put that emit particle stuff in this rendering pipeline, and then I needed like solid geometry, so I just drew a bunch of cubes. And it turns out this was really, really fast, like ridiculously fast. And so then I just kept pushing it. And so here's another one of these, just another shot of that. And I kept kind of these same test lights as I was testing this, and you'll see that they look a little familiar. in the intro as well, and you probably already recognize them from the last scene. And then I started playing with PBR and getting better materials in here, which you can't really see too much, but you can see, again, emitting some kind of basic geometry particles from some kind of object. And it's the same stuff here. And I've started playing with, different materials based on where it was being spawned from. Fast forward a couple weeks, and again, because I was pretty inspired by Number One, Another One, I wanted to see if I could do some stuff with mocap. So I started looking into that. I think this is the next screenshot I have, and already this is the kicking guy from the demo. And this is September 23rd. So this is actually a while into how I figured out how to do this. Essentially, though, what we're doing is, let me open up this tool here. So what we do is we process these files called BVH files. And so let me just pull one up here. And this is a tool called BVH Hacker. It's just some like open source tool just to be able to take mocap. So I don't remember where the mocap came from. It was some royalty-free online martial arts kind of mocap thing. And I went through a bunch of different ones. I ended up picking this just because I liked this motion. But mostly I was just testing with this initially, and I just ended up making it in the demo because I ended up just not feeling like it needed a different one. But the idea here is that this is just the skeleton, so there's no real model here. It's just the motion data itself. And if you look at a BVH file, I can actually pull up what this looks like because it's all textual. And the format is not that complicated. Let's see, have it in Trashpanda assets. Here's the value, the thing itself. So initially in this file, you have a description of the hierarchy. So you have just like a list of these joints and how they're connected together. And then you have the motion described as frames. So at different parts of the hierarchy, there are these channels here. So for example, X, Y, Z, position, rotation. And these determine basically how the coming from the origin of the parent node, like how you transform the space to get to where like the child matrix for the child node. It's a bit hard to explain, but it's relatively simple when you think of the code, because it's essentially you just generate a matrix that does each one of these things, and then you multiply it by the matrix of the parent, and you get this. It's not quite exactly that simple because of this offset and stuff, but it's roughly that. And then what happens is then you have these frames down here. So you have the duration of a frame in seconds, the amount of frames, and then each line here is a single frame. And I got word wrap here, so that's why this is the entire thing. And then each one of these floats just corresponds to the input to one of these channels, and they're in the same order that they are described here as sort of this depth first order. Gee, Superland, did I get a finger tattoo? No, that's totally green screen glitch.
I'm still waiting for you to get the Logicoma tattoo.
Yeah, I need to get the Logicoma one. But as soon as I get it, you have to get it. That was the deal.
That was the deal, yeah. Yeah, that's been agreed by my wife as well, so.
Yeah. So then I have to do it.
Mm-hmm.
By the way, sorry I'm missing stuff in the chat. I'm totally on my way here. Anyway, so this format is relatively simple. But then it comes down to kind of how do you actually compress this? And I ended up trying a bunch of different stuff. In fact, I might have even done this publicly. I don't remember. Because I made a couple repos on GitHub. One of them is BVH. And I think I used this code exactly as it is now. I just made this to start to parse the file format. And this, I think I used pest here, which this is the description of or this is the like BNF form or whatever it is. Isn't that what it's called? I don't remember. And then the library itself is relatively basic. So I parse that into this BVH structure, which has the hierarchy in motion. The idea here is that it exposes that exact data, like in the exact same kind of structure, just with Rust data structures, so that I could do whatever I wanted with that on top of this. So then the other repo I made is called mocap. Whoops. And this, come on, give me the address here. I'll share this as well. So this actually contains all the stuff that I did to do the compression and everything as well. And I just did this in a public repo because why not? And then, of course, I have movie quotes as the description. Bonus points if you know what movie this is from. Anyway, this whole thing is really basic. I think it just uses the BVH library. And what I was doing here in main was testing how I could actually compress this. So what I did is I wrote first a thing to be able to using the BVH parser. I would actually get the actual data, and then I would transform it into whatever internal structure that I planned on using in the demo. And then what I would do is I would write that back out so I could get kind of a round trip thing. And then I started playing with how this data would actually be compressed. And what I ended up, the format that I ended up with was actually really simple. So instead of, I still store all this hierarchical data, but instead of having these channels where you have like just sort of inherently the order of where all the data is going to come from, in the binary packing that I do in the tool, I just end up, for every channel, I pack in like a byte for whatever kind of channel it is, and then just all of the float data for that channel. So it's just kind of rearranging the data, but it's how I actually pack the data that ended up being a little bit clever. All I ended up really doing is, if you look at each one of these lanes, so each one of these would have been kind of inlined in that hierarchy. If you actually graph some of these values, I should have prepared some of these, because what I ended up doing is I dumped these to CSV in that tool, and that might actually still be in here. Yeah, the stuff actually is in here. So maybe, hold on here. I really want to show this because it's kind of cool to see this. Just want to, I use this thing online. It's called Plotly, and you just upload like a CSV and it'll just show you the graph. And I think I should have some CSVs laying around when I was testing this. Upload a file. Yeah, stuff.csv. And I think this will actually show, if I remember correctly, this ends up showing the actual data that gets compressed. Yeah, I may not be explaining this the best or being that descriptive here, but just bear with me here. Anyways, if you treat this as just like a list of floats, like that's really the only thing that we need to compress, is we have a list of floats. And so the first thing I thought of was maybe I can take some ideas from audio compression, because that's also just kind of a list of floats. So the first thing I do is I took some inspiration from FLAC. And what FLAC does, it's a lossless codec, and so originally I wanted this to be lossless. And the first thing it does is it normally does some quantization, because normally you don't use floats for those samples. You use like 16-bit values. So I end up doing that first. And that is actually a lossy operation, but it ends up being that you have no difference when you're using like 16 bits, or no noticeable difference when you're using 16 bits to actually store each of these values. So the first way you can compress this is, instead of 4 bytes per float value, you can get 2 bytes per value by just doing 16-bit values. So what I end up doing is per one of these channels, I store the minimum float value and then the maximum float value. And then for each value that I store after that, it ends up being just a normalized value. So if it were the minimum value, it would be 0. And if it were the maximum value, it would be 65535. So that's relatively basic. But then we can go a step further, because that doesn't actually compress that well. So then what I started doing is I started looking at some predictive stuff. So let me actually pull up Paint here. Or actually, it's easier if I just write out the code. So I started looking into something called linear predictive coding. And there's, if you Google this, you'll actually find a lot of stuff, because it seems to encapsulate a lot more than just sort of the main idea. But if you look at, I think it's shorten and something else. Let me actually look at this, because if you go to FLAC format, you get to the zif.org site. I'm just kind of showing you how I found this stuff. And somewhere in here, there's the prediction part. So just to take a little step back here, I'm going to draw some pictures in Paint. I like how I feel like I'm just as scatterbrained as I always was when doing these streams. So this, you can imagine, we have some kind of waveform here that we want to compress, and let's do a noisier waveform. So this is if we're doing audio compression. I figured that this would also work with mocap as well. So if we store this as a bunch of different samples, we'll have different sample points along this thing. Not terribly important. But the idea is what you want to do is if you look at this, you have a lot of this like low frequency content and then a lot of this high frequency content. And if you can sort of separate that, then that's going to be really helpful. So what you want to do is you want to essentially like make some math function that given for a given sample position, you look at the last couple samples and you do some kind of math with those values. And what you end up with is some kind of prediction for what this sample is going to be. And that prediction is going to be some distance away from the actual sample. And so what we do is we call this the prediction, and then we call this the residual. And so what we do is we have some math function for doing the prediction, and then we just store the parameters to that function. And then for every value, we just encode the difference between what the prediction was and what the actual value is. So in code, it ends up looking something like let prev samples is some buffer, and then we can do like prediction is prev samples 0, so that would be like the last sample times coefficients. We'll do I here. We can do let prediction is 0, and then for I in 0 num. Actually, we can just do coefficients in coefficients. We'll do like coefficient and then the index. And then we do something like this. And it's literally this simple. And so then what you need to do is you need to find these coefficients. Right? So this ends up being a relatively easy problem. And this, there's a lot of research into actually doing this for a lot of different kind of codecs. But what I ended up actually doing is I just said, okay, well, why don't I just start looking at some subsets of these because I was feeling lazy that day. So what if I just made the coefficients array have like 3 elements? And I made each element something like 7 bits or something, and I just brute force tried to find all of them. And when I did all that, I ended up finding that there's a certain set of coefficients that ends up compressing this kind of data better than any other one. And just to give you an idea, it's basically this, where the first, which means like the previous sample, gets multiplied by 1, and then all the other samples get multiplied by 0. This is actually a subset of this mechanism, which is exactly equivalent to delta coding. And what delta coding is it's just this. So let last sample is 0 for index in, let's see, index in samples, or let's do sample in samples. Then we do encode sample minus last sample, and then last sample is sample. That's the entire encoding. And I ended up finding that through this slightly more complicated scheme. But it turns out that this was by far the best. And that actually makes sense because they don't move very fast if you actually look at those. And then the decoding is really basic too. So this is let last sample is 0, and then for index in num samples, then we do let sample is decode index plus last sample. And yeah, and then we do last sample is sample. So this is basically all that delta coding is. And I mean, that's kind of an obvious choice if you want to look at this kind of data and say, like, what's a nice way to do this? And this would be kind of an obvious choice, but the fact that it worked this well after kind of testing it with the more general way felt pretty good. Another thing we could have done was curve fitting, which Daniel Collin here mentions. But I was too lazy for that. Pyro says that coefficient looks a lot like how you use a window in FFT calc. That's exactly what it is. It's exactly the same idea. But yeah, that special case where the last coefficient, the last sample is 1 and then all the others are 0 is exactly equivalent to delta coding. And then if we know it's delta coding, we can do that a little bit simpler, which is just this. Anyway, so that's basically what I do for compression. And it really isn't much more complicated than that. There is still the whole thing about like quantizing. And what I found was that you can actually get away. So initially I did 16-bit quantization. So that's literally just taking the floats that were in this file and just normalizing them to 16 bits. But what I found is that even if you do like delta coding, you still have a lot of noise. If you quantize that to a smaller number of bits, like 7 or 8, you actually still get something that looks almost identical. But then the things you encode here, these differences between the prediction and the residual, end up being a lot more similar just because there's less possible values that they could be. And so that ends up compressing a lot better. So it turns out that just having a number of bits to quantize by and then doing this delta coding. For example, this kick animation was originally a few hundred kilobytes. Of course, it's textual, but still, it's still fairly large. And that ends up being, I think, let's see what I used in the demo tool. If we go to kick dudes, which is this scene here. There's the kick dudes here, mocap. Yeah, I end up using 5 bits for this, for the quantization in the actual scene, which sounds like it would be really bad. In fact, I think I even have a round-tripped file for this. So this is what it looked like coming out of processing. And if I play this, you'll notice it's a little bit shaky. But other than that, there's not much different here. And that shakiness in this case is kind of masked in the actual scene by the fact that there's a lot of particles coming off the guy, because like I had with those tests earlier, I just started emitting particles from the skeleton. And the fact that the particles also add kind of noise, it kind of masks a lot of the noise that you would normally see in the mocap. So that worked really well. And I think that, again, that few hundred kilobytes of mocap data originally gets down to about 3 kilobytes, which was totally my goal when designing that. So the next thing with that mocap stuff, I'm just going to keep going, by the way, until someone asks me something or Ian steps in. But the next thing is how do I actually get this stuff in the shader? Pyro says, what kind of coefficients did I test before using the 1, 0, 0, 0? What I did is I decided that I would use a small number of bits for the coefficients because I figured I could just get something representative and then just increase the number of bits if I found something that would work well. What I did is I just said, okay, I'm going to use like 3 coefficients and then like 7 bits for each. And that gives you 21 total possible bits. And you can actually just search that brute force. And I did a bunch of combinations like that. And all of the ones that compress the best by far all had that same structure where it was 1, 0, 0, 0 or like 1.025, 0, 0, 0, like some fairly small number. So, I mean, it's all about what gives us like the best prediction, and then ultimately what makes not necessarily the best prediction for, like the best prediction that gives us samples that code small after. So you just kind of have to like empirically, like test and look at the data. So this is the exact data that gets packed for that animation, and as you can see, a lot of the values are very, very similar, and that's what ends up making it pack really well. And it makes sense too, because a buddy of mine actually said this the best way. It's Baggers, by the way, if you look him up on Twitter or whatever. He said meat doesn't move that fast, and he's totally right in the sense that like you're not gonna get much information from a few samples back because it's gonna move so slowly anyway. So a lot of the stuff that's focused on audio, I think, generally deals better with a lot of high frequency data, whereas this just doesn't have that kind of content. So delta encoding ends up being the best we could do. I think there's a lot of other ways this could be coded. this is just what I did. So I got that in the tool around September, and then the way that we actually get this into the shaders is by populating a shader storage buffer. So what I end up doing, let's see if I can look at the shader here. Kick dudes, particles, segments. No, this is drawing the lines between the particles. We want not compute data layout. Compute, I think. Maybe it is this one. Here, mocap segment buffer. So the idea is that I do all the transformations, all the hierarchical stuff on the CPU, and then what we get out of that, as you can see from here, is a list of transformed segments. And we could do a lot more with these segments, like we could do motion vectors and stuff, which I planned on doing, but ended up just dropping for running out of time and laziness. But anyway, we get a bunch of these segments where they have like a start position, end position. I just have those in some kind of like local space. And then the buffer is just the amount of segments and then that many segments. So if I want to, for example, emit particles from that, it ends up being really easy. I think it's down here somewhere. Yeah, so I just take something about like something based on the instance ID for the particle that I'm going to emit from. And this is actually in a compute shader, so it uses this invocation ID and like work group and stuff to actually figure out where it's going to look up in this particle buffer. And then I think I used that to make this grid thing, and then I ended up hashing some of that stuff. Oh, no, it's even simpler. I actually evenly distribute these between the different segments. Yeah. So I just do some math on that to figure out which segment it's going to be in, and then in there I look up that segment, and then here I mix between the start and the end with some hashy stuff that uses time, so just figure out where along that segment to emit the particle, and then some scaling and some other stuff. And it's really that simple in terms of actually using this. Yeah, I thought that was interesting too, Pyro. It was not the expected result that I would get, that delta coding approach would actually be better. But it totally was once I actually put it to the test. So that was really satisfying. So I think the main things tech-wise was the stuff for making the synth faster, which I did a lot of on stream, and then the mocap stuff and the multiple variable types. And I don't think there was much else that actually happened with the tooling. But yeah, it all kind of grew out of that particle test and then adding mocap and stuff. And so I had some shots of that from pretty early on already. This was the first one. And then I played around with some other things like different materials. I did some really glowy stuff where it would offset the particles and then add a bunch of emissive stuff. I didn't end up using that in the demo because I forgot about it. So I think the code is actually still in there, but I didn't expose it or use it.
You're wasting space, which I could have used for audio.
Yeah, no kidding. Yeah, so actually, speaking of wasting space and also wasting time, so a little bit about the timeline of this demo. Like a lot of this test stuff was being done in August, September, which is really nice because, like I mentioned, it changed jobs and moved and everything. So it was kind of a stressful time. It was nice to be able to just like focus on just some kind of project like this. And another thing I ended up digging into was our compression tool again. Long story short, there were about 2 weeks before the party where the first week I worked almost only on that packer, and I have some more stuff that I want to show on that as well. But then the second week was all on content, and we ended up not using the packer because I thought I had gotten the compression good enough to where it would beat Crunchy, which is the existing one that everyone's been using for like 10 years. It turns out by the time I actually got everything to the state where it was a working packer, I had to put more stuff in that compressed section, and then it ended up being that my compression is actually a bit worse, and my unpacker is a little bit bigger. But I do have a working compressor now, which is really cool because now I can start actually tweaking that a little more. I don't necessarily want to share numbers about that or anything yet, but I do want to share some of the report stuff really quick while I'm talking about it because this is actually fairly cool. In fact, I'll actually pull up one of the things here. So I should have some output here. Where is it? Gets in squishy. Yeah, here, report. This is a 92.5 megabyte HTML file. And I think looking at the executable icon, it looks like this is Vessel by Conspiracy that we're about to see. Yeah, the compression rage was very real. I've improved it since those last couple weeks. Like in the last few weeks, I've been working on it a little bit, but it still needs a lot of work. I'm really excited for when that's actually usable. We're actually a couple kilobytes under 64K with Crunchy, but we're like 1.5 over with MyPacker, so we didn't end up using it. Oh, this is loading so fast. I might actually run Engage through this really quick because it doesn't take long to do that. Let's see who will win. Squishy. Oh, here. Squishy Corpus, Demo Scene, Logicoma, Engage.
Aha.
Oh, there it goes. All right, we'll just look at this then. G. Superlin says, are you still thinking about doing a post-release with the new packer if you can get it down? Maybe. I would actually like to repack all of our intros when I get the packer working and kind of release those as a pack. And because that'll also address some of the fixes for the other ones, like proper resolution selector and stuff that we've done sort of as our tech has gotten better. It would be nice to have that in the old intros too. So I'd like to repack all of them at some point. It'll also make the synth faster. Maybe things will be a little smaller, maybe not. I actually gained 0.5 kilobyte just by updating Rust at the party, by the way, but that's another thing. I expected it not to work, but we got 0.5 kilobyte anyway. Yeah, there's still stuff because stuff and stuff. Anyway, so I would like to do that, but I don't think I'll do a final version of this demo because there's a couple things that I would change, but nothing really super interesting. Anyway, this is a report that's generated by the tool, and what's kind of cool about this is it just uses HTML here, and if we look at the source, I thought we'd at least be able to render some of that quickly. Guess not. Yeah, it doesn't matter. Anyway, I just use these HTML spans here and then some CSS to be able to show, for example, I can hover over one of these. Maybe I can't. Yeah, it says exactly how many bits this byte actually took up. But what's cool is it shows like different sections for things. Like here's one of the reverse code transforms that it has. Here's the import code. Here's the disassembly model thing that I have in here. Tables for that. Here's some model parameters that actually do compress a tiny bit if I put them in the compress section. Here's the function import data. Here's some other data, which I did some cool compression stuff with, and the text. So the idea here is that I'd be able to see where in the code it's compressing well and where it isn't. But yeah, there's a lot more stuff that I need to do here. And it doesn't quite compress as well as Crunchy at the moment. We're about 6 kilobytes off, I think, in total. That includes extra depacker size, which I know I can get down to. So there's a lot of work to be done there. But overall, I think we'll close the gap relatively soon, finally. But yeah, this was just kind of something I worked on as well. More stuff. Yeah, I bet the stream encoder loves that. That was a proper robot cough, by the way. So let's see. So let's just go over some more of these screenshots like I normally do. Eventually, one of the things that I had was this shot. Freezy said, have you tried porting your renderer to some API that's not deprecated by Apple? Nope. It's all OpenGL still. It's OpenGL 4.5 now too because of the compute shaders. Before it was 4.1. But yeah, so I had this shot, and this is exactly the same thing, like emitting particles from the mocap skeleton, except what I do is I just decided that there's 3 of them, and I just pick a random one. In fact, it's not a random one. It's based on time or something. Let's see. Compute there's this figure index here that just says mod of time of something. And then there's also this force dude parameter, which I can make it to force a specific one, which is kind of funny. But basically, based on that figure index, we just adjust the spawn position. And then I think later it calculates I think I copied and pasted this code. No, I didn't. I use it here. It's mixing the different material parameters based on the figure index. So that also selects which kind of material it is. And this is just stuff that it dumps into this big compute shader buffer that has all this information in it, which is in here. And then this is picked up by the actual rendering and the segments buffer, and then this gets stuffed into systemd buffers and all that stuff. Hey, Moliv, how's it going? Sorry if I'm missing a bunch of stuff, but I'm missing a bunch of messages. Yeah, Metal would be what we need to do on Mac, but I'm not using Mac anymore, and because of the compute shader stuff, I dropped Mac support with that. So if I was going to use a lower level graphics API, it would be Vulkan. But I don't think that's something I'll ever do for this tool. We wouldn't really get any benefits because performance at that low level really isn't something that is a concern for us right now. And there's a lot more like setup, and it's just more finicky. So GL45 seems to be okay. Anyways. So that was that shot. And then I was also playing around with like camera angles and depth of field and stuff, and also decided which font I would use. And let's see. I think around this point is when we started getting soundtrack previews.
That'd be about right, I think.
And so this would have been like around mid-October already.
About 2 weeks before the party, I think it was.
Yeah, that's when I started pressuring Ian about like party's coming up soon.
Yeah, it was a welcome distraction, I think is probably about the best way I could put it without going into too much detail.
I mean, that's good to hear.
Yeah. Actually, there's if you look at the starred files, if you would go to the top one, you can actually there's a preview of something like a false start, which I guess is part of the creative process is that you start something, and it was all right, but it's it obviously wasn't fitting the vibe. Oh, do you know how to look at starred files?
So I just found the thing for that, but it looks like starring is per user.
You're joking me.
I mean, it says I haven't started anything, and they're not showing up.
Right.
So good thinking.
Yeah, that didn't quite work how I planned it, did it?
No, that's okay. Let's see if I can find this. Because it would have been before inducted, right?
Yeah.
Or
so
let's
inducted.
see. Inducted.
Inducted.
For
due to a typo.
WST1C? No, that's too early.
No, that is a bit after. If you go to that message, you should just scroll from there. It should be fine.
TRSAC 19.
What is that?
I'm gonna hit play. You ready?
Yeah.
So very different than what it ended up being.
Yeah. That actually, I've handed you that and we're like, yeah, maybe. And then we, I think I've been listening to a lot of Drum is how you're supposed to pronounce it, but it's spelled DJ Rum.
Okay, I didn't know that actually.
And there's a track, Inducted, which I dropped onto you, and you were like, that is exactly the kind of style that we need to go for, which is more kind of slow yet fast. So it's kind of at drum and bass speed, but it's a lot slower.
Exactly.
Kind of,
so
it's done with kind of half time.
At that point, I basically only had these visuals.
Yeah.
Something like this. And so that's what I wanted, is something, like, especially if you look at the post-processing and stuff. Specifically, like, clicky was kind of a key word. And that fast but slow kind of thing, exactly like you said. So,
yeah.
So, yeah. Sorry, I didn't mean to interrupt.
That's fine. That's fine. So I think it was the second night after that, just fired up the project again, like just a blank sheet, and started again with. So if you check the first preview, which was basically just the drums.
Yeah, I think I've got that here. It's quiet, but already that had the right vibe.
Yeah.
And
obviously that just kind of progresses and progresses until we get. And obviously, I think we got probably about 3 days in, and I've been chatting to Nobi quite a bit on a super secret Slack team. And he'd actually mentioned that he'd never done a collaboration musically with someone before.
Oh wow, I didn't know that.
Yeah, and had not even used Ableton that much, so I thought, two birds with one stone, and pull him into this project. So I'd already done quite a lot of the kind of groundwork just to kind of get the direction and where we were going.
Yeah, I think I can play another one of those actually.
Mm-hmm.
So this is Inducted 03.
Mm-hmm.
And as you said, this is from 2 days after.
Yeah.
Already you have like a lot of the melodic elements.
Mm-hmm.
The piano.
The GM piano.
I want to open up Ableton and look at that in a minute.
Yeah.
In fact, I should start that now. Yeah, I'm just noticing this is a 2-minute preview. So like within those 2 days, it's already like this much fleshed out.
Yeah. That reminds me, I really need to switch to the dark theme on my Ableton.
Yeah, disco theme.
Yeah.
Let's see. So much is already here.
Yeah. But that's just a testament to the workflow with Ableton and the synth, really. Like, you can really smash stuff out with it really quickly.
Shameless plug.
Yeah.
By the way, Wavesaber rules.
To answer your question, Pyro, do I start with drums? Mainly, yes, because it is the backbone. But sometimes you could start with just a chord progression and then just kind of, expand from there. And then, it depends kind of, if you can start from one end with a chord progression, then you need to find drums that fit that. Or if you find drums that have got a vibe that you want to go for, then it's finding the melodic elements for that. Multi-band sidechain. The multi-band sidechain doesn't exist yet. But I am building one. So, and it doesn't, it's it kind of works apart from the fact that it's really twitchy. So when you plug it in at the moment, it destroys the right channel in the first instance.
I think eager might be the right term.
Yes. So that's hard to see. So as you can tell from there after day 2, essentially the first half of the tune's pretty much done. I think Nobi had come in at that point and put in those absolutely amazing chord progression in there, which when he first sent me the preview, I just fell off my chair. I was amazed. And he did an absolute ridiculous amount of sound design work on this as well. Like just extra layers that you probably wouldn't notice. It's a slightly different structure actually than what we normally do in terms of grouping and folders and stuff, because we'd usually just put in an audio track and then feed into that. But instead this time I've used group tracks, and then so the big, I think that's like a yellowy one that you've got there. That's where basically pretty much all of the drums are.
Yeah, and you
So
didn't just use them, you implemented support for them in the converter for this.
Yeah. So the converter didn't support it, but it was essentially about 3 lines of code to get it to do it.
I love when that
track
happens.
graph, because obviously the way the track graph works, because it's so kind of basic and simple, it can totally handle all of this. So in that drum section, there is basically nothing but adultery.
And that's the GM-DLS device.
Yeah. So everything in there is pretty much.
Can you guys hear that,
solo
by the way?
that.
Should be just making sure that works as I expect. Yeah, it looks like it does.
So yeah, there's actually a bit of a design choice on doing it that way, because both Adultery and Specimen have this slightly nasty bug, which we can't get rid of now, where the output on them is really quiet. And because we've used those now, we can't change it.
Specimen 2.
Yes.
Adultery 2.
Definitely. Another point on this one is it's probably one of the smallest tunes we've ever had, I think, in one of these intros.
Yeah.
It's only about, I think it's about 24K with
Small
the player
for us.
all compressed. Yeah, so it's really small. The only 2 samples that are imported are the kick drum, which is pretty nice.
And this is the smaller one. This is the 11 kilohertz one.
22.
22, yeah.
Yeah. So obviously that goes through the GSM compressor. No, there is no cowbell this time. So that the GSM compression kind of put quite a lot of artifacts on the sound of that. So we just kind of put an envelope filter, a low pass filter that just shoots straight down.
Oh, that's the yeah. So this looks like just super quick decay and no sustain on this low pass here.
Yeah.
So like if I turn the sustain up, then you really hear the noise.
Yeah.
It's subtle, but it's there.
Yeah. So it really helps kind of just clean that up into a nice thud.
Yeah, especially because this is so central in this track.
Yeah. I suppose the other thing is obviously on the side chaining, which some people thought was a bit much. I'd be slightly inclined to agree.
Yeah, I don't, frankly. But, you know.
Yeah. Yeah, so that's actually driven by...
Tasty.
So it's not driven by the kick at all. So if you look, there's a kick key in there. And that is just, if you can hear that, which you'd have to change the output on it.
Which is, I can just do master.
Yeah.
Ow. So this was Duck Me 3-4, wasn't it? Yeah, good.
Yeah. So the reason why I do it that way a lot of the time is with an actual kick sample, it could be quite large in terms of, its tail. So if you have it that way, then you can really kind of, tweak up how long it lasts for and balance that out however you want.
And I guess just a noise burst is just a nice cheap.
It's not a cheap way of doing it, but it also, if you use a kick, because the sine waves are quite slow and long, it can actually affect how the sidechain reacts with that.
Yeah, that's a good point.
As I noticed that when I first started playing with sidechain, and I put the attack and decay really slowly, and it just makes them crunch.
Yeah, I never noticed that, because I usually high pass a kick when I sidechain with it. So you kind of just get this anyway. But I mean, this is a much more general approach, I think, and like more controllable approach to actually just generate the noise blip.
Yeah.
So I think that's pretty cool.
So yeah, there's a few bits of sound design that nobody's done in here.
Yeah,
which would be in that massive
point them out.
Yeah, I will do. Can't really see it on your screen, so I'm
Okay.
just loading up Ableton myself.
Yeah, one of the ones that I like while that's happening, because that'll take a minute. I like this electric wiring sound.
Oh yes.
I think that's really cool.
So that's what you call the happy accident. In the fact, I think I was playing with adultery and trying to find something melodic, kind of clicky kind of sound, and then accidentally moved all the MIDI notes 2 octaves up, and it makes the oscillators run faster than the sample of the loops, so they end up just being weird electronic noises. There we go.
That's so cool.
So you wouldn't even notice that, like, unless you know that they're there. They're really hard to spot.
Yeah, I didn't end up doing as much sync with a lot of those kind of sounds because I mean, Tio always gives me crap for not syncing to like every sound, but to be honest, I don't think you should.
No.
Like from a direction standpoint, I think I like to think I strike generally a pretty good balance on like what is important and what's not. I think I may have missed a few in this soundtrack because there's just so much that I could have synced to, but I don't know. Too much and it just is tiring.
Do I also code in the synth? Yes, I do. Because Ferris is not really that bothered by it anymore. So
True. I did most of the like when I worked on it, that was mostly 2012 to 2014 or so. And that had to do with like the core architecture of the synth and the initial devices and just making it all work and then producing executable music. Hoff and I started working together on just tracks in like 2013, and I think you had the code already by 2014, 2015.
Mm-hmm.
and Hoffman just kind of took off from there, and especially implementing new devices and making sure the converters, first of all, worked right, but also like adding a bunch of converters for different project formats more recently.
Yeah, so we've got FL Studio support at the moment. Renoise support, although you can't do any sidechaining in Renoise because Renoise is annoying like that. Obviously Ableton support, although I haven't tested 10 yet. And I'm just kind of on the cusp of finishing the Reaper support, which we did have before, which you did originally, right?
Yeah, that's actually the first thing I wrote.
Yeah.
And I dropped it when we were going to move to open source because there was a library that I depended on for my own for parsing the Reaper format that I didn't want to have open source anymore. I just wanted to get rid of it. So we just kind of dropped it, and no one was using it anyway. So.
Yeah, and for some reason I'm a bit masochistic about trying to get as many DAW formats supported as possible. So,
yeah,
the good thing about that is
what?
The good thing about that is that's all in C#, so it's like it's totally my comfort zone. So I could just sit there and do that all day.
Yeah, because that's literally what you sit there and do all day for a living, right?
Yeah, pretty much. Yeah, yeah. But except I'm shifting people's address information around rather than floating point numbers and MIDI data.
What's the difference?
Yeah, one of them, if I get it wrong, it crashes. The other one, if I get it wrong, I break the order flow for a multi-million-pound company. So,
No pressure.
No pressure. So a few more bits on this. Yeah, the low piano and is probably one of the best ones to go for because
I really like this. We'll do this one here. Some more notes. Tasty.
So yeah, so all that is Adultery, which is our GM synth with one of the low. Oh.
I just played it raw. So this is
Raw.
just the sound itself. So this is one of the piano samples that comes with GMDLS. By the way, GMDLS, for those of you guys that aren't aware, it's literally the sound font file for MIDI on Windows, and it's been the same exact file since like 1996. Ships with all versions of Windows, and you can literally just load it. I think we even have a hard-coded offset to where the sample table is, and then just pull as much sample data you want out of there. And so this device we have, Ian did most of the work here in actually building like figuring out what this interface would be, so we can adjust, like, we basically pull out the samples. I don't think we pull out any instrument data about them.
No, not yet. Not yet.
but we get like the sample start and end from that and stuff. Or actually, do we even parse that? I think we just set it manually.
Yeah, pretty. I think we put our start point and then we just read forward from there, I think.
Now I remember that these different loop modes. I think the first one uses the parameters in the sample, and then the other ones are custom, and you can adjust like sample start whether or not it's reversed. So I can like doesn't do much with the envelope and stuff. But anyway, this will just play that sound raw.
Yeah.
And then it sounds like MIDI. It's a long sample.
It sounds awful, doesn't it? Yeah, and then after that, to make that obviously sound a lot better, the kind of pianos down low when they're reverbed and got quite a nice low pass filter on them still sound quite genuine. So you just punch the low pass filter on and then soak it in reverb.
Yeah, so this is raw. No wait, this is raw. And here's this with the low pass. Luna said, so even if you had GL4.5 on Mac, you'd be held back by lacking GMDLS. I mean, yeah, but we could like pack that with the synth if we wanted at least to support composing on Mac, but that's a whole other issue. But yeah. So this is the original low pass. I kind of want to hear this higher note too. So already it sounds a lot better just ignoring a lot of the really tinny stuff. And then the reverb. By the way, this reverb also is another one that Ian did last year, I think. It was just an implementation of Freeverb. And this is tasty. Oh, that's nice.
Love that reverb so much.
Freeverb is really nice because it's relatively cheap and very parameterizable.
Yeah.
So it's very good to have. Very small.
Just thinking there's a few bits of sound design that Nobi did which I really love, like the sweepy.
Sweepy, here we go. Woof. Oh no, these are actually relatively basic curves. Oh, proper FM stuff here.
Yeah. What was the drizzle?
Yeah, GC Berlin, there's a stereo spread. So the GM's, what comes out of the GM stuff is mono. I think we have a panning parameter in Specimen. I don't recall.
Yeah. It's it is a panner, but it's mainly for the voicing.
Oh, right, yeah. So if we play like multiple voices, we can have them sort of spread out in the stereo field.
Yeah.
I don't think this piano does that because the unisono is all the way down, so that's just going to be mono.
Yeah.
But then the spread or the width, I think in Freeverb determines in the feedback network how that stuff is panned, I guess.
Yeah. It's basically got a set of the left side has a set of values for the reverb, and the right side has its own set of values.
Ah, right.
I think the key, when I was reading all the source code and stuff about it, is that as a reverb, it's really basic. It's just got a bunch of all pass filters and a small bunch of comb filters, and I think the way they designed it was just basically finding the sweet spot for all of those delays. Yeah. And once they found those, that's it. That's your sweet spot, and you're done.
Yeah, I guess it's a mix because with the comb delays, you're getting mostly just the delay effect more than anything else. Yeah. And then I think the all passes are just adjusting the phases after that, so you don't get the tinny feedback stuff. Yeah. To be honest, I don't really know how any of that stuff works beyond literally what I just said.
That's about it. It's really good that people are out there putting this stuff up for me to read, not understand, but implement beautifully.
Exactly.
Making Euro. I love that, Frizzy. Have you thought about making Eurorack modules out of the Wavesaber plugins?
Oh, that'd be awesome.
That would be awesome. I'd love to make Falcon as one, actually. That would be amazing.
Yeah. By the way, someone earlier asked if it was going to be open source eventually, and absolutely. I can't really say when, because every time I do, we never make it. But
That's very true. Yeah.
but it will be open source, and that is definitely getting closer and closer.
Yeah. This is working now for me.
What is this? This says needs a better sound. What's that sound
Oh,
like?
that's a synth that I didn't like, but it stayed.
I really like this. I think that adds so much. That sound to me tied that whole last part together.
Yeah, it's lucky. So the one thing, just from a composition point of view, there's kind of, as far as I see it, there's like 2 or 3 stages. The first one is getting it initially off the ground.
Yeah.
As a melodic idea that you like, and then you can kind of expand on that, and then you make your first section, and then obviously, most of the time we do this thing where we have 2 sections of the tune because then it gives the demo somewhere to go essentially.
Yeah, in this case it's like this quieter intro-ish bit, and then the big takeoff. Is that kind of the main sections you mean?
Yeah. Yeah, so the big problem always ends up being is that I finish up until the first section at the end of that, and I'm like, that's all great, I'm all happy with that. I then have complete writer's block for the last section for about 3 or 4 days, wondering where the hell to take it.
Yeah, this was not the first idea you laid down.
No.
This whole vibe here.
That was one of the other ones in the previews, but yeah, I think originally it just kind of did the same thing, but with some extra layers to it, and it just didn't feel like it was going anywhere. So
yeah,
thankfully we scrapped that.
And I think especially with because I think if I recall correctly in the previews, you kind of had the rhythm here laid down, and then I think was it Nobi who did the chords?
Yeah, so he did all the pad stuff. The chords in the second section are actually ripped off of Nobi's part in the latter part of the first section.
Ah, right.
But what I found out by looking at it the other day was because they kind of sound different. It's like kind of more. Is it dissonant? Is the word I think I'm looking for?
Yeah.
And the result of that was I think he's got like a 5 or 6 note chord that's happening in that last section. And when I copied it, 3 of the notes didn't come across.
Oh wow!
So it just ended up sounding different, which was perfect. It's exactly what we were after.
Is that in something or soft pad? Nice.
It's not very soft, is it?
That was quite sharp. But it just, oh man, it works.
Yeah. That's the other. If you solo the wind chime.
Is it called wind chime?
Yeah.
There it is. Oh hey, this looks fun. That's actually awesome.
So that is if you play a single note of that with all the effects off, you'll see what we kind of what we had to deal with.
Already there, just with the that's awesome with the velocity, which you also added recently.
Yeah. There's going to be more of that kind of stuff popping in there eventually when I find some time.
Okay, so this actually has a lot of that content in it already. So I think my favorite part about the way that we use this GMDLS stuff, like GMDLS has been used by the demo scene for like 15 years already, at least. A lot of, I think most of it I've seen used in 4Ks, where a lot of the earlier synths would just be sample players with some MIDI data. But it's really this ability to post-process them and layer them that's kind of key here. To actually make these sound good, because they're not good on their own. I mean, there's a couple of nice ones. I actually still like the default snare that's in there. And a couple other things, but and all the 808 stuff is great because it's authentic enough.
So handy.
but I mean, in terms of especially melodic sounds, it's really lacking. But you can always bring that back. So I think this is going to be a good example of that if I can shut up and hear it. So that's raw, and already you get a lot of that layering from this, literally overlapping them in the different velocities, which is cool.
Yeah. So if you just hit like a single note on its own, I think you should just play it rather than just play a long one. Oh yeah. Yeah, pretty much that.
And then the echo here, which is going to be like a delay.
There you go. Adding the necessary space.
So already together, like it feels like one big together sound already, and then with with the reverb on top of that, fills in all the holes. Tasty.
What on earth is that?
So that's really cool. What is this, by the way?
What is that?
Sucky Plinks.
Sucky Plinks. Oh, so that was something that Nobi put in, and then I repurposed it with a different set of MIDI. I didn't realise it had so much. Oh my goodness!
And this is still one of the smaller ones, so that's fun.
Yeah.
I mean, it does look like this is the same over and over again.
Yeah,
which will pack really well, because I think I just delta code all the different events or all the different automation things. So this should pack really well. I'm so happy with this soundtrack, you guys. It turned out to be such a cool vibe and just fit the visuals that I had really, really well. I mean, the later visuals that I added, of course, were meant to match this, but you know.
Is it the drizzle?
So much cool stuff.
So that's basically the another one that is always that we do a lot. We do it almost every track, and we do it to the kick drum that we always have, which is the. Oh, there's a couple of tricks in here actually.
Yeah.
You go right to the top. Let me zoom out myself. So you just get the first destruction kick and solo that.
Does it start really, or what is this?
Sorry, not the top, not destruction kick riser. That's the second one. We'll go through.
Okay, yeah.
So it's the other one.
Thunk.
Yeah. So it's a simple trick. All you do is you take the kick drum, you low pass it, and you soak it in loads of low pass reverb, and you just end up with this wall of bass that comes out of it.
Yeah, this is a kick. Compression, bit crush, reverb, low pass compression. Big sound.
Yeah.
Especially at the end. This is really nice. Thunk.
And the other one is it's a duplicate copy. So another thing to remember is that obviously when we're importing our own samples, like the kick, because that's a GSM compression that we use for that, obviously that is held within its own instance within that device. So the data is in there with that device, which means that if we could use the same sample again, but what happens is obviously we duplicate the whole device, and then obviously we don't try not to change any parameters so that the data is the same. But what happens is the compressor comes along and sees that both the samples are exactly the same and just goes, well, we only need one of those. So we don't actually get that much of a size hit by duplicating the same sample over and over again. So the destruction kick is it's a little trick that I do with the reverb. So if you just play that section on its own.
The solo of the kick.
The top one.
The top one.
That's the one, yeah.
Nothing.
Yeah, wait for it.
Oh, it comes in after a while?
Yeah. It didn't need that long a box on it, to be honest.
Here it is. Oh, I know what you're doing.
So that's a trick with the I think it's a freeze.
Yeah, exactly. The freeze and then the. Where does the rest of that come from? Oh, that's leveler. Right.
Yeah,
this
leveler.
Is cool.
So the reverb has a function on it called freeze, where basically it when you switch it on, it sets the feedback to 100% and stops anything coming in. So if you just it's like if you held a button on it, then the reverb would just continue at that level until you switch it off again. So what we do is we play the kick with, so we put leveler on the end to bring the volume right down so you can't hear anything. Then we play the kick through the reverb and switch the freeze on, so you just get this wall of noise.
Yeah, so without the leveler.
Yeah.
It sounds like the kick is screaming.
Yeah. And yeah, so we then just use the leveler to put a volume rise on that to give it a nice kind of kicky rise.
And you can see that curve here as it comes up. Swoosh. And these two together. I think there's also the kick here.
Yeah.
Get all that for the impact. I'll turn this off. Oops. No. Thunk. Yeah, that's a great trick.
Yeah. It's funny because we've had that reverb for quite a while, and I've been dying to do that ever since I noticed the freeze button and what it did. But it's taken until... actually, the first time I did it was in the Bros Before Foes, just before it says damn. So the damn sample goes through that massive reverb and then fades up and then drops in on its own channel.
Frizzy said, does it waste CPU while the leveler is set to 0? Yes, it's going to run that whole synth that entire time, because these are different devices, and the synth will run all devices that aren't explicitly disabled. In fact, it would run those too if the converter would put them in the synth. They're stripped at that time. So it'll still run, and you actually want that in this case, because you don't want it to just freeze its state if the volume were 0. And you also wouldn't really have a good way to do that, because all the inputs to this would need to be disabled.
Yeah.
So yeah,
I
it's
mean,
still running.
Yeah, you're right. There's because of the way this is structured, that means that, I think if you look at things like 4 clang and 64 clang, for example, they're very much centered around the voice. So you have the effects within the voice. So when the voice stops playing, it shuts everything off, which doesn't really work very well in a scenario when you want to put 30 different plugins all over the place in a DAW. So although there's a bit of a trade-off of, obviously, we're going to be running devices and they're not really going to be doing anything, so we are wasting CPU speed, but we don't really have a problem with CPU speed since we've done the last round of optimizations like the SSE and the changes to the filter and stuff.
Yeah, most of that was just SSE. Just switching to SSE got like 50% performance increase on a lot of songs.
Yeah.
And all we really did for that, was change some compiler flags and replace some functions that were missing after we did that. And then the filter optimizations is just, I literally opened the synth in a profiler and just saw some hot paths in the filters where it was like recalculating some coefficients that it only needed to do when stuff actually changed, but we were doing it every sample. So just moving some of that, and that's it. Like, that's most of the optimization that was done.
Flipping that box would literally count as optimization.
Yeah, like if we do this, then this is not included in the output anymore.
Yeah.
So that would get smaller and faster.
Yeah, but thankfully we don't seem to run out of CPU that much these days, which is great.
Not for lack of trying.
No, I keep trying. Yeah, since the last round of optimizations, I haven't had a problem. We haven't really had a problem at all, particularly since the SSE stuff went in, and it was so nice to get rid of all those denormal hacks. It was, they were very annoying.
Yeah, that was I think the biggest reason why moving to SSE helped, is that when you're using the FPU, you have these the floats, especially in feedback networks, which there are a ton of in synthesis. Floats get really small and they go into denormal mode, and then processing them is like 100 times slower or something, because I think on Intel CPUs it drops to microcode to do that, which is ridiculous. It basically traps to microcode on every floating point operation you do, which is it's laughably bad. But SSE, you can disable those. You flush them to 0, which means they won't ever output denormals, and you can say denormals are 0, which means any denormal that comes into that system, if any, is going to be 0. So it's just some flags once you're actually using that stuff. So SSE does have denormal mode, but we disable that whenever we actually do any audio processing. Also, G Superland mentioned, he said, I noticed the demo was really efficient in terms of effects that it achieved for the GPU usage. But thank you. Most of that had to do with the fact that it's just a polygon renderer. I don't think it's and a lot of instancing instead of just like a lot of draw calls. So there's honestly there isn't much to say more than that. It's just doing what the GPU likes to do.
Yeah, I suppose the last little bit that I really like about this particular project is the shitty vocal,
Yeah.
which is an 11 kilohertz vocal sample.
Yeah.
Yeah, so if you switch everything off for that, you'll probably hear how bad it is.
I'm excited. Ugh.
It doesn't actually sound that bad on the stream, but okay.
Garrett Kelly, thanks for the sub. I don't know why my notifications didn't work. I'll fix that later. Oh no, I never did that for subs, did I? Anyway, thank you so much. But yeah, you definitely hear the warblies.
Yeah.
So quick thing here, when we're doing this like sample rate drop. No, it's here. So this is what the sample actually sounds like, right?
Yeah. So what we do is, because we could probably improve that on the import way in for the samples, but because you only use 1 or 2 or 3 or 4 or 5 for the project, because obviously it will only take a 16-bit 44 kilohertz mono sample. Anything else it will just throw out. So the way we trick that, obviously our sample player can play the sound at any pitch that you want. So what you can't do is resample it, because that changes the properties of the WAV file to say it's 11 kilohertz. So you just do a pitch shift on it, so it still thinks it's 44 kilohertz, but the physical data is either halved or halved again.
Yeah. So this gets a quarter of the length now, but then when we play it back down here, we get the original. But of course, since we're playing it lower octave then, and because it'd be the same if we lower the sample rate, now we have a lot less high frequency content, and that's why it's muffled.
Yeah.
So, but then I guess some compression. This probably just makes it louder. Yeah, that's what I thought.
Yeah.
And then the leveler, low pass to get rid of the warblies.
Yeah.
And then reverb, obviously. And then that already is thick enough and sounds nice, and then the echo is gonna just do the delay, I guess. And I love too with the echo. This is one of the best decisions I made in the synth, if I do say so myself. The feedback network has these filters in it, and all it does is it just applies these filters in the feedback network. So I think as it writes into the delay buffer, it just runs these filters, low pass and high pass, and so it cuts out a little bit more of the low every time just because of this filter. And I love those effects because you get, like, I think you can take a really simple reverb or really simple delay, and there's always going to be sounds you put in there that are going to sound like crap and going to sound really muddy and just have a lot of frequency content you don't want. And as soon as you just filter that, it just works.
Yeah,
it's the easiest thing.
That's exactly what we did with Cathedral. So Cathedral's the same.
Yeah.
The original, when I first, because I found a pre-compiled version of the reverb, and I just tested it in Ableton and thought, well, the reverb sounds good. I wonder what happens if I just threw a fab filter on it just to like kind of see what it would sound like with a low cut and a high cut, and it was just like, wow, this is exactly what we need.
Yeah.
This is great. So I just implemented it, basically just copied the bit of code from there into there, and then it makes it so much more useful just having those 2 parameters on there.
And this low cut and high cut here, this also runs in the feedback network of the reverb?
I can't remember. I can't remember whether I just put it on the input stage or whether it's in the. I don't think it's in the feedback network. No.
Because I would imagine that would actually introduce some phase weirdness too, and then you get like different kinds of like tinny sounds.
Yeah. Especially you'd have to incorporate that in 8 all pass and 4 combs.
Yeah.
Multiply that by 2 as well, because it's left and right. So
right.
That probably wouldn't have been a great idea. But I mean, even just being able to take that texture out so that the main sound has all of its frequency range, and then the reverb is only focused on what you want to come out of it. It really helps.
Yeah, I really, I really like that. I mean, that's tricks that we use in high-end music that just kind of just made sense to put in this. I think that's kind of like philosophically, as far as the synth goes, a lot of this stuff is relatively straightforward. It's just stuff you would do anyway. It's just the fact that it's there and you have the workflow. But we'll get to that in a later talk.
Yeah. Is it Will Smith that is sampled in the Price Before 464K? It is not. I imagine you could probably, in fact, you could probably find it on YouTube if you just type in "Damn Son."
Oh, I'm sure. Is it the "Where'd you find this"?
Yeah.
Yeah, no, exactly. I have that in here somewhere, but it's gonna be faster to find it on YouTube than on my hard drive.
Yeah, a 4K video download it.
Damn son, where did you find this? There's just so many of these, just like.
Damn son, where'd you find this?
Awesome. That's gonna get my video taken off of YouTube now.
Yeah.
Worth it.
Yeah. So I think that's about, I mean, there's a lot of other little details in this. Little effects.
I like obligatory ARP also.
Oh, which it's got like a very 80s retro vibe to it.
This is the Stranger Things sound.
Yeah.
Dum. Dum dum dum. Anyway.
Yeah, the obligatory ARP. So I mean, as sound design's concerned, that's quite an easy one to do. It's just a little bit of a envelope for
the
you
filter.
just kind of you put like on the filter and the amp. You just kind of create a little up and down like that. Kind of really get that kind of shape. Sounds like an old Martin Galway tune.
What?
Sounds like an old Martin Galway tune from the '64.
Totally.
Yeah. Let's have a look. I think that's pretty much. Yeah, I mean, pretty much all the drums came from Adultery. I think, the bongos, everything. Crikey, there's a lot of them. There's. Yeah, 19 channels of drums.
We've done worse. Pops and then the kicks and snare and stuff. And the bongos. Nobody was really on the fence about those, and I'm happy that we just toned them down instead of getting rid of them.
Yeah, so glad. You sanitized them. Is exactly what he did.
But how do you think that collab went?
Perfectly. I think if you see on the Poe thread, someone was like, I think it was, I can't remember who it was, but they basically said, I don't hear Nobi in this tune at all. And he said that he sees that as a compliment because he just kind of jumped into the way and the direction the track was already going, which is, it's a skill in itself to jump into a track and then not just, take it the wrong direction or whatever.
Yeah, I think that's cool and commendable and all, but I also just disagree with that original comment. I mean, I'll say, of course, that it sounds like a Logic Coma track, right? And there is something to be said for like trying to fit that style, and I think he did a great job. I don't mean to take away from his comment when I say that. I just think that I totally hear him in this, in a really good way.
Yeah. I mean, there's a lot of the sound design work he did on this is just, I mean, yeah, it's something that I'm all right with. I'm not too bad, but no, but he's just, I mean, he's mental at it. The stuff he does with Four-Clang is unbelievable.
I totally agree, and it's stuff that you and I would not have made, and and definitely chords that you and I would not have made.
Yes,
and it really adds to the vibe here. So Really cool.
Yeah.
It's definitely still a Logic Coma track, but it definitely has its own flavor, and I'm just very thrilled with this.
Yeah. Yeah. It was really. It was. I mean, it's great to I like doing collabs at any time really, particularly when it's with this because it's really easy to transport it around.
Yeah.
So all you're talking about is one project files and a handful of VSTs that aren't on different versions on different people's machines, which is great. It means everything just loads and works, which is great. So yeah, if anyone's interested, tap me up.
Yeah, and that's to get access to the synth and start using it, because you have been letting people in and getting at least the plugins we're getting to people now. I think we're still more or less holding the converters and stuff back. Mostly, there's some people that have that, but
well, the converters are there, but they're kind of encased in something that you can't play. So
right.
I know you can play it. So the point of there's like a little project manager application that comes with it now that I just knocked up in C#. It's really basic, but basically you can open your project file from FL Studio, Renoise, Ableton, or whatever, and then you can play it. It will tell you if there's anything wrong or if there's anything that you're doing that isn't supported by the synth. And then you can play back the track through the Wavesaver player, which is obviously pre-compiled. So you can at least verify that what you're doing in the DAW is actually right and working correctly and sounding right. But obviously, yeah, if there's any musicians out there that want to give it a blast, tap me up somehow. I'm sure you can find me on the internet.
Yeah, and if there's any DSP heads out there,
yes,
please do the same.
Yes, come and speak to me in the dark corner.
I think it's going to be really cool when the synth is open source and people especially start making their own modules for this, which is kind of the dream.
Yeah.
There's so much potential here. I feel like we're barely scratching the surface.
Yeah.
So. But yeah, maybe that's enough for the soundtrack for now.
Yeah.
So I'll go back to some visual stuff. I think at this point, I'll just continue going through some of the screenshots I have here and just show how kind of some of the stuff developed, kind of visually. I feel like there are not that many scenes. I think there's like 3 or 4. I had plans to do a couple more, and I ended up just saying, you know what, I'm just going to do some longer form shots. It fits with the soundtrack. Maybe if I hadn't spent so much time on the Packer, we would have had 1 or 2 more. But I mean, the nice thing is I still have the ideas for the next one, and like this renderer that I built for this demo, we're definitely going to reuse. And I also want to add some stuff. Like currently, there's just spotlights and like some fake environment mapping, which is done through spherical harmonics, which is a nice small way to do it, more than anything else. And it doesn't support much more than that, to be honest. So like I want to do ambient occlusion and some other stuff. But anyway, so this was the first thing that I was working on. And the whole thing is that like I showed that there was emitting these particles. And to draw them is just literally like some shape that's instanced. So in this case, it's a icosahedron, I think. And then that's instanced however many particles there are. And then we just place them in the vertex shader based on the stuff that from the particle update. And then these lines between them, I just duplicated, so we have shader include in the code itself. So in our shaders, we have, for example, we have stuff like the particle light map vertex shader, and then this, of course, we'll use this particles of GLSL. There's the particles, particles itself. No, hold on. Particles gbuffer, so the gbuffer pass also has that same stuff. And then the particles that GLSL actually does all the magic here. And this is the thing, it's just placing all that. So the nice thing is we can say like the compute data layout, all this is we can just include this in other shaders so the code doesn't branch out too badly. So then the particles themselves are being drawn just by instancing those shapes. And then we have the segments as well, which will actually pick 2 random particles from that buffer. So it instances a bunch of cubes and it picks 2 random particles from the buffer. And then you kind of have the line segment that forms between those. And then we place the cube in the middle of that and we scale and rotate it so that it, is essentially the line between there. And since the particles themselves have lifetime as they kind of fall out and die, we also scale that cube based on that in the other direction. So they get kind of smaller as they as they go by. And the fact that the lines go like between the different kick guys here in this scene, that's just the fact that it's all the same particle system. It changes where we emit the particles from and which material the particle has when we emit it. So just the fact that they're all the same system is why we get lines between them. So nothing really too fancy there. And then in order to do that orientation for the lines, I'm not that great at vector math. I talked with mentor of TBC, and he was telling me that there's a way better way to do this. But I just do some trigonometry where I figure out the angles between them and then do some basic rotations. And that's good enough for me. Frizio9 says, spherical harmonics, can you elaborate? And I can actually paste you the exact thing where I got the code from. That's the spherical harmonics. I mean, the idea here is that if you want some like low frequency data, let me see if I can draw this. You basically have some point, and you have some like light sources and some things in an environment that are kind of shining light towards your point, and you want to simulate this. And if you look at this, it's like the output of like these two lights would be rather low frequency, because you'd have like a lot of this red stuff here, and you'd have a lot of this blue stuff here. So if you kind of look at the sphere around this is kind of how that would be colored. And of course, this would like fade out on this side and on this side, and then this would fade in and out on this side. And you can actually, you can simulate this really easily if you have like the two angles here. So if you have an angle that goes around here, and then you have another angle that goes like this, you can basically represent any point that's on the sphere. And so if you just have some function that given those two angles gives you a color, you can simulate stuff that would give you enough simulation of this kind of light with like 2 or 3 sine waves that you just input these angles into, and they have like an offset for the phase and a frequency, and then you have one of those per color channel. So it's really that simple. The code here, I think I just took this code. So it gets even simpler when you have like a normalized vector that you can sample this from, because then you can kind of collapse all the trigonomic stuff. And the point is you have some kind of environment, and then you can get the coefficients for this math, and then you let me pull this link up here. You put these coefficients and you multiply them by the different normal components, and then you have some representation of that environment map that's expressed just by having these different coefficients. So it's a really cheap way to do some kind of faked environment map lighting, and it's not dynamic in the case of the intro. In fact, if I go, let me see the code there. I think it's in here, end map. I just have the code here, the Eucalyptus Grove one that's just taken from that website too. And yeah, literally just you look up in the direction. Now, one of the things I did wrong here is actually getting this value back into the PBR stuff. And it ended up being that it looked cool anyway, and I could just make it really dark. So I didn't end up doing that properly or trying to fix it, because I just liked how it looked anyway. So we just left it broken. So if I turn off all the lights here, a bit hard to see because I don't think there's much of it on this scene, but all the lighting you see on these objects now is from the spherical harmonics. I think you can see it more on some of the background objects, but it's definitely way too bright for what it should have been. So I think I multiply this by like 0.007 or something. So this is what it is otherwise. But kind of what's important when you do this environment mapping with this low frequency stuff is it's just that you, as the normal changes, like the reflection vector changes, you get different kinds of lighting. So you kind of get the important parts of that effect just by having that in there. So that's what the spherical harmonic stuff is. It's really basic. And then, of course, the scene just has the different spotlights. So there's this blue one, and this white one, and then this pink one. But the reason I was talking about the segments and stuff, too, is that the next scene I started working on was just kind of a different permutation of this, because I knew I wanted to do credits, and I knew I wanted to do some kind of particle effect behind some text. So ended up with this triangle scene here. I'll go to the Darth Shader one because you can see it the best here, where it's actually like the full triangle here. And
I really love those. They are amazing.
I think they turned out way better than I expected. And I mean, so from the earlier shots, I was showing how I was emitting particles from like a shape. So this is literally just bringing that back, and then changing the material parameters is basically all I did, in terms of the difference between this and the mocap. It doesn't use the mocap; it just uses the shape again. And this is the original shot I had. It was too dark, and it was just the particles themselves and didn't have the segments. Let's see, what's another shot of that? This came together really fast when I was playing with this. It's kind of the next one. Starting to tweak this material parameter and the fonts as well. It's really simple stuff, but it's just one of those things that I think it just kind of works. I was playing with the exposure, so things get a little brighter here. And I also had this gradient, the circle gradient in the background. I just moved it to the top left, like little things. That was an idea I had when we did Elysian, and I just moved it to the top and then put the logo in front of it, and that's the whole end of that demo. And then here, this is I started playing with that like orangish color, and that's actually, if you go back to the Kick Dudes, there's 3 of these guys, and this one on the left, it's literally the same material. So some of them are black and some of them are this bronzy kind of color. And I just reused that. So kind of being lazy, but at the same time, it gives some consistency, which is nice. Frizzy says, why does it animate while the timeline is still? And that's the reason is that the particle update happens in a compute shader. And the fact is that there's no, that still runs every frame. So it's still like the demo itself is still running, and we still get the timestamp from like the delta time between 2 frames is what's at the input of the shader. So I guess I could do something where I could just make that 0 when the timeline wasn't running, but then we'd have issues of like, if you skipped around a bunch in the timeline, they'd be all wrong. And anyway, this just, yeah, the particle system is still running is basically the short answer. So yeah, so that was coming together. And then I think the last shot I have of that is just more tweaks. I think I just made it brighter. Oh no, I was just playing with depth of field. I did end up cranking the exposure a lot here. Not too much, because I think the whole demo is generally pretty dark, but I think that fits the kind of sparse feeling of the soundtrack, so that's kind of what I was going for. At that point, I wanted to try something completely different, and I wanted to do something really quick and easy because I was feeling kind of demotivated that I wasn't coming up with ideas. So I went back to our old demo, Almost Infinite, and I didn't copy the code, but I copied the same idea. So a bunch of instance cubes. These have different materials, and there's actually proper lighting on them, so I think it looks a lot better than the Almost Infinite version did, but it's literally the same stuff. And I have some of these shots that I think are really cool that we never ended up using in the demo, because I actually couldn't recreate them by the time I actually started putting everything on the timeline. But anyway,
that's the Game of Thrones chair, isn't it?
Yeah, exactly. It's exactly what it is. But I think some of these are kind of neat. It's a really cheap kind of scene to make, but as long as it looks good, then it's fun. And that's also where the colors in here are, again, it's the same kind of materials that I had in the other scene, where like some of them are black and some of them have that goldish color, and then I just have the same lights that I was reusing throughout the whole demo, because I would just copy the scene, and then that had the lights in it. And one of them was this pink light, and when I just cranked that up, it made this really nice red color on that orange material, and then the white stuff got pink here. So it like, I just really liked how this looked, especially with the depth of field on the far stuff. And then that kind of made this sort of pink and yellow and whatever color kind of stick throughout the demo too. Because at some point I wanted things to sort of match up a little more, and that's why I turned down the blue light in the kick guys as well, from my earlier shots. At some point, I also did this shader. This is just, I wanted to do some 2D stuff, and I want it to be behind the title screen, and so I made this. I actually have this on Shader Toy, but it's not public. I should probably make it that. But let me pull that up. Because it started by just doing some FBM stuff, and I would sort of make these pattern generators, and this is not, I didn't want it to look so Petsky, but by the time I actually implemented these, that's just kind of how it looked.
I love that fact that it looks like that. That's
yeah,
my favorite thing.
And it's really simple. Like, I think each one of these if you just look at the code here, we figure out where we are on the screen, and then so we have some kind of pattern selector, which is just some noise function thing, and then I saturate that, and then that goes into this SDF, and then we figure out some different slashes and stuff based on where it is between 0 and 1 here. So that's really basic. And eventually I changed it so that these shapes would kind of crossfade between each other when it was between those instead of just selecting one. And then, of course, I made it a lot smaller, and I added these kind of rings. So by the time it was all done, it kind of looked like this. Then you start kind of seeing the actual thing. This is what it looks like in motion on Shader Toy. And it has a bunch of other stuff because it has like FXAA and stuff, even in the Shader Toy example, because I was playing with like Vignette and Glow. It's actually another shader that I made public with like the glitch effects from Engage, and I actually have to put it back with the original shader again. Because I think at the bottom of this, there's actually that other shader. This is just something I threw together, so I was pretty lazy about that. But that ended up being the title screen. If I go around here, see my cameras are all messed up, so now this scene looks all stupid. This is that same scene as earlier, but then just with mirroring, which is always such a nice trick. Yeah, so this stuff. And again, it's really basic. It's that same noise stuff. But then, of course, we have the chromatic aberration on it. And then I also did some coloring, so that's more FBM stuff, and it just selects white or pink or this blue color that I just tweaked on there. And then, of course, we fade in the sort of ring effect, which is just some distance from the center that affects which shape it is. And the text here was kind of cool. What I wanted to do is I wanted to have this Trashpanda text here and just have it scaled down slowly. And when I added the scaling factor in the shader, I added it in the wrong place. So that it ended up doing this kind of like mirroring effect here, because it would just repeat the texture within the bounds of that text. And so then I just started playing with, like, if you do like an integer value, like in this case it's like 8 or something, then you get the thing repeated 8 times. But if you do like a non-integer value, then you just get parts of it. And so this is just modifying by hand whatever that value is over time. And in addition to that, I also put it in the right place, so over time it also does actually get smaller. But then there's just some blurs and stuff, and that's all this scene really is. A little bit of flicker. But I think that turned out really nice. When I was making it, I just thought it was like super ugly, but I just liked it anyway. But now I think it really fits with the demo. What else do we have here? Other work in progress shots and whatnot. Am I going the right way here? I actually don't have that many more work in progress shots here, because I think that was really all the scenes there were in the demo, wasn't it?
Yeah. You've explained the bunch of flowers.
Yeah, so yeah, did I actually explain this? I don't think I did. So the way this works, there's basically 2 draw calls here. There's actually 3 because there's some stuff in the distance. Let me actually look at this here. It's called grow. So there's the background objects, and that's just these dodecahedrons or whatever that are just way far in the background, and they catch like the light and shadows and everything, so they look kind of nice. But that's just there to just fill space. And then the objects themselves, there's 2 parts here. There's 2 draw calls. One of them is the segments, and then the other one is the stuff at the end of the segments. And so if I turn off the stuff at the end of the segments, we can kind of see this grow a little bit. I think there's another, maybe the close-up shot is easier to show this. It's going to look all wrong. Oh, it's this one. Here. Except now my camera's in the complete wrong place. So let me just move. Just hold undo until I get the demo back. There we go. So turn off the endpoints. So the segments, it's just a bunch of instance cubes again. Instanced cubes. So if I go to the beginning of this, you can see them kind of grow. And the idea is that there's a certain number of segments that these are all made out of, and each segment is going to be drawn as like a cube. And so you kind of just want to if you imagine you can have like a matrix and then that represents the transform, and so you kind of plot a cube and then adjust the matrix by like doing some move and a little bit of rotation, and then you plot another cube and then plot another cube. It's basically that idea, but with different random seeds for the different, I think I called these strands are the different things, and then the segments are the parts that make up the strands. And then finally you plot the endpoint thing at the very end. Of course, I did this in a shader with instancing, so the way I do it is a little bit fancier than that, but it's exactly the same idea. So let's see, and grow in segments. No, it's in globals. So I have these matrix generating functions, and what I do is I get a matrix for a specific segment. So what I do is I take like an identity matrix and then I rotate it in a random way, and then I just literally accumulate this in a for loop. And then the different shaders will use these. So like the different cubes will figure out which strand they're a part of based on the instance ID and also which segment they're a part of, and then just call that function to see how they should be transformed. And then the endpoint will just call it with the last index, and that's how you get that. So yeah, exactly, Two Curbs, a turtle graphics technique just done in a shader. And it's kind of ridiculous that I can go this far, like doing all these matrix transformations per vertex, per instance, and like the ones at the very end are going to do this entire loop, and then the ones lower down are going to do less of them. But apparently this was really fast, so it works. But that's really all there is to that effect. And then there's some clever ways in how that code was shared, but it's not really that important. And then of course with all the lighting and the rendering pipeline and everything, we get shadows and stuff. And there's some bugs here with that. This kind of shadow mapping is kind of hard to do. To get without artifacts, so that's just how it is. But that's really all that scene is, and then there's just a couple different lights. There was this white one and the yellow one. And the yellow one was originally that pink light that I had from another scene, but I made it yellow to make it more match the credits. That's all that is. Yeah, exactly, Two Curbs. It's not the worst way to do it as long as it's still fast, and it is. And here I think the environment map stuff actually helps a lot with this look. So this is no lighting, so you just see the objects. It still has depth of field and everything. It's the same depth of field and same bloom that we've used in previous demos, except I did improve the bloom. I think I had a stream about that around April or so. But yeah, turn this on. This actually does quite a lot for this scene. Just adding all these lights from everywhere on all the faces that don't actually face the user. Again, it's not correct in terms of how the end map should look, but it just looks nice anyway. So it's very hacky. Frizzy said it's shadow mapping in the demo tool. Also, the shadow mapping is actually implemented in the demo tool. So the way I do that is I have this scene function, and down here, like it'll call the spotlight function. And before it calls the scene function, it'll set some global variables, just like basically what pass there is. Like there's a gbuffer pass because it's a deferred renderer. There's a light accumulation pass. There's a post pass, all that kind of stuff. And so the code within the demo tool will set the kind of pass and then call the scene function eventually. So I think this is the gbuffer pass. This is the light accumulation pass. So when the light function gets called, this is kind of clever, but hard to get right. When the spotlight function gets called, it actually checks the traversal mode. So if it's like a gbuffer pass, it won't do anything because you don't want to draw the lights in this case. But if it's the light map traversal mode, then what it's actually going to do is set up the light projection transform to be like the inverse transform of the light or something. I don't remember. Or no, this is just the projection of the spotlight. And then we do a light map accumulation pass or a light map drawing pass or a shadow map pass where we change some of that global state and we actually call the scene function again. So then it'll be drawn from the light's point of view with some different traversal modes. So then when it draws the other objects, those will have a different shader for the shadow maps versus the gbuffer stuff. And then, so it'll draw the whole scene again, but then when the scene function then calls the spotlight thing again, it will early out on the traversal here. So it's kind of this weird recursive way of going back into the scene function per light. But it ends up working really well. So it's kind of, yeah, recursive deferred rendering. That's exactly what it is. And then the next thing it does after it generates the shadow map is it sets those parameters back and then draws a full screen quad into this light accumulation buffer where it actually applies the lighting to the G buffer stuff using the shadow map. And normally when you're doing deferred rendering like this, you would actually draw the light bounds more conservatively, but in this case I only have a few lights, so I just drew everything on the whole screen, and it was fine. That's laziness more than anything else. No, my demo tool is not public, unfortunately. Someday I would like to make it open source, but it wouldn't be something I would support or document that well anyway, to be honest. But I think that's all the scenes that are in here, really. And not that much more I actually had in my head to talk about. Beyond that, it's more just showing different like work in progress shots of some of these. Like this was one of the earlier shots of this. Some more where I got this camera angle that I liked, and then the mirroring, and then I added the yellow light in here. I think that's about it for what I wanted to show, to be honest.
Let's just see if you scroll through the preview chat channels.
Yeah, that's exactly what I'm doing.
There's a lot that you don't want to show on the screen, is there?
Nope.
What is that? It's the cup.
Yep. That's when you had a great day.
Oh yeah.
I mean, there's some of these shots too. Like here's some earlier versions of the scene with the lighting that looks a lot worse. I think if I were to do a final, that's actually one of the scenes I would revisit. Because I think it ended up a little too dark. But I don't think it looks bad. I just think it could look a tiny bit better. But overall, I'm really happy with that. Especially like the depth of field as it comes around here. I think is really cool. Overall, I think I'm really pleased with this demo. I think the most disappointing thing about it for me is that I didn't get to use my own packer. But the next one should. Frizzy said, do you do any offsets to the shadow map to prevent artifacts? Yes, and I do it based on the dot product of the normal of the surface versus the light. So you get kind of less artifacts at grazing angles, but there still are artifacts. If I turn off the depth of field, which I'm too lazy to do right now, there's actually a bunch like on the edges of these of the floor here where you see that. And I think in one of these other shots, like this straight on one, you can actually see not all the shadows exactly touch the object either. So there's a lot of bugs. But I think for the first demo with this render, I think this is good enough. So a lot of those things I'd like to address now before we do the next one. But overall, I think I'm quite pleased with this. And it does end up being a lot more performant than a lot of our demos. I think our demos are generally okay on performance. I think this is one of the better ones just because it's doing stuff that a GPU likes to do. Like if you're just doing a lot of instancing, you get extremely good throughput through the GPU. We're a bit wasteful on like how big our G buffers are. Like I think almost everything is float 32 or float 16 just out of laziness. Could do a lot better packing there. Like I think I pack full 32-bit world space positions in one of the G buffers, and that's okay enough for this PC focused demo. But yeah. Anyway, if you guys have any more questions, I guess we can take those now. And other than that, we'll just take those and then be done, I guess. But I also really like this demo stylistically. I think it's one of my favorites that we've done now. Just in terms of, I watch a lot of motion graphics and it looks like this, so I really like being able to kind of pull that stuff off now. Getting a critical mass of just like sync tricks and tech.
Fire triangles.
Yeah, I thought it was funny when someone pointed out that it looked like it was like a triangle on fire effect, because I never really thought it looked like fire at all. To me, it was just weird metal, but it totally does look like that, and it's cool.
That's all I thought. I
Yeah.
didn't even think you didn't realize it was fire.
That's so funny, especially with the depth of field. It really looks like that. And I love just the framing on some of these shots. Like it's the simplest thing to just move the camera around like that, and I like those kind of just edits where it's just hard cuts between those. But I just really like how it looks. Frizzy said, can you elaborate on the segment particles? So I think you mean like the lines that connect the segments here. So the particles themselves, there's a compute shader and a shader storage. There's a shader storage buffer with all the particles. And then there's a compute shader that just updates those. So it reads and writes in the same pass. And that's just doing some basic, is it Newtonian physics? where you have like you have a velocity and you update the velocity with some acceleration, then you update the position with that velocity, and then that just feeds back. So really, really simple stuff. And then to draw them, we do one instance draw with that will actually just take the Euler integration. That's what it is exactly. And so then to draw the particles themselves, we just do an instance draw, and then each one of those pulls pulls one of the particles from the buffer and just places the primitive there. And then the segments, we take the instance ID and we do 2 hashes on it, and one of them picks like a starting point index and one of them picks an ending point index. And then we just look up those in the particle buffer, and then we have the segment between those. So then we draw all those as instance cubes, and then we place the cube in the middle of the segment and orient it so that it links up the segments. I believe I described that a little bit earlier, and I did some like sine and cosine math to actually do that, but some trigonomic stuff, because I'm not that great at vector math and linear algebra. So I had my trigonometric hammer, and this problem looked a lot like a nail. But that's literally all there is. It's just those instance cubes that are kind of placed in the middle of those segments, and then picking those 2 from the buffer. Also, for segments, like, for example, what if those when you pick those things out of the particle buffer, one of them is dead? So for those cases when either particle is dead, I just generate the cube where all the vertices are at the origin. So that's just how I sort of cull those, and then I also scale them along the like lateral direction, or whatever direction it is, based on the lifetime of both particles. So yeah, the segments are all cubes, and then I think in this case the primitive that's drawn for the particles is a tetrahedron. I just played. I have a bunch of the platonic solids in here from when we did Elysian, and then that's just played with different ones. Hey, Michael C. Yeah, it's good to be back. So unless there's any more questions, I think I'm gonna head out and get to bed at a human hour. And of course, you guys know where to find me on Twitter and stuff. Again, I will start streaming regularly again. It will be at this new 7 o'clock time slot instead of 8 o'clock. So hopefully you guys can catch that, and that's no problem. Thanks again to Ian for joining me on this.
No worries.
Really happy to have you actually dig into the music that I'd never really even opened until until tonight. So it's really cool to go through that stuff too.
Cool. My pleasure.
And also thanks for working with me again on a fun demo. I think this was really fun to make.
Yeah, our problem is we're running out of styles to play with.
Yeah, exactly. Exactly.
I'll have to get RC55 in. Maybe we can do a happy hardcore tune. Maybe not.
Oh, no kidding. Future Bass is another one that I think would be fun. Still want to do a demo with pastel colors. Anyway, thanks guys so much. I'm really happy to see you guys all joined again, even after it's been so long. It's good to be back, and I will definitely see you guys next week. So yeah, thanks again. I'll see you guys next time.
Bye.